This video is continuing 6.5, which is our operations with functions, but now we're going to focus on writing composition functions, both evaluating them and just writing them in terms of x. We're going to start with example 3. Now you've seen composition function notation before earlier in the year. It looks like this, f of, there's an open circle, g. It just means it's the function f evaluated at g of x. So I'm plugging in the g of x function into the f function. And it could work in the opposite direction. If I would have had g of f of x, that would be the g function being evaluated at the f of x function. So plugging that into the g function. The best way to explain this, though, is just showing you examples. So we have some modeling problems and some try problems. Starting with example 3, I gave you an f of x and a g of x function. For part A, I would like to evaluate f of g of 2. So the first thing you're going to do, step 1, it's let's figure out what g of 2 is going to be. So we're going to find g of 2. That means I need to plug 2 into the g function. So g of 2 equals, I'm going to plug in a 2 wherever I see x. So g of 2 equals 2 cubed. If something is squared, we multiply it by itself. If something is cubed, we multiply it by itself 3 times. So this is 2 times 2 times 2. Or 2 times 2 is 4, times 2 is 8. So g of 2 is 8, which means now we can plug 8 in place g of 2 and find f of 8. So step 2 is to find f of 8. So that's function f evaluated at 8. I'm plugging in 8 wherever I see x in the f function. So that's going to be 3 times 8 plus 1, or that's 24 plus 1, which is 25. So our final answer is f of g of 2 equals 25. So we're basically just plugging in a value twice. Let's do it again. Now we're going to do g of f of 2. So step 1 will be to evaluate f of 2. So I'm going to plug in a 2 wherever I see x in the f function. So that's 3 times 2 plus 1, or 6 plus 1. Which equals 7. So now that I know that f of 2 is equal to 7, I can plug 7 in place of the f of 2. So step 2 would be find g of 7. So g of 7 equals, I plug in a 7 wherever I see x, so 7 cubed, which is 7 times 7 times 7, which would give me 343. So my final answer is g of f of 2 equals 343. I'd like you now to do the 2 try problems. So pause the video, attempt those, and hit play when you're ready to check. Part A, we had f of g of 3. So step 1 was to find g of 3. For g of 3, I'm going to plug in a 3 wherever I see x. So 3 squared was 9. So now we're going to replace the g of 3 with 9, meaning step 2 is to find f of 9, which I wrote here. Plugging in a 9 wherever I see an x, that's 2 times 9 minus 3, or 18 minus 3, which is 15. So f of g of 3 is 15. Part B, we had g of f of 3. So the first thing we would want to do is find f of 3. So if I plug in a 3 to the f function, I end up with 6 minus 3, or 3. 3 will replace the f of 3. So step 2 is to find g of 3, which I wrote here. Plugging in a 3 where I see x, I end up with 3 squared, or 9. So g of f of 3 is equal to 9. All right, example 4 is writing composition functions. So the way that this is different than example 3 is that we don't have a number that we're evaluating it at. We're just going to leave it as the whole function. So if it says f of g of x, we're plugging in the whole function g of x wherever I see x in the f function. So really, this is f of g of x, which is 2 over x minus 1. So I'm plugging in 2 over x minus 1 wherever I see an x in the f function. So that means it becomes 5 times 2 over x minus 1 plus 2. Let's at least clean this up. So this is 5 over 1 times 2 over x minus 1, which would give me 10 over x minus 1 plus 2. If you wanted to add this together, we'd have to multiply the 2 by x minus 1 over x minus 1 and solve from there. I'm okay if you just leave it like this since I already tested you over that, but feel free to find a common denominator and add. And whenever we have a quotient, we want to state the domain. So there is a restriction here. It's going to be undefined when x minus 1 equals 0. So x cannot equal a positive 1. So I just set that equal to 0. That's how I got that answer. Example B, we have g of f of x. So that means we're going to plug the whole function f of x into the g of x function. So really this is g evaluated at f of x, which is 5x plus 2. So wherever I see x in the g of x function, I'm going to replace that x with 5x plus 2. So that would be 2 over the x becomes 5x plus 2. And I have that minus 1 there that I need to bring over. We can combine like terms here. So I'm going to put 2 over 5x plus 1. So this is the final answer evaluating it. However, because it is a quotient, I have a denominator, I need to state the domain. So I need to set 5x plus 1 equal to 0 and solve for x. We had some mistakes on this on the chapter 5 test. So I would have to subtract 1 first, leaving me with 5x equals negative 1. And then to get x by itself, I divide by 5. So x cannot equal negative 1/5. If it does, it would be undefined. At this point, I'd like you to do the 2 try problems and make sure you go back and state when it's undefined. Hit play when you're ready to check your work. Alright, so we had the function of f being evaluated at g of x. So I'm going to plug in the whole g of x function wherever I see x, making it x over 1 minus x squared minus 1. Now, there's our properties of exponents. We reviewed that in the 5.6 introduction, which says we can distribute that power. So it becomes x squared over 1 minus x squared minus 1. Now, you cannot distribute the power when you add or subtract. Instead, what we'd have to do is rewrite 1 minus x squared as 1 minus x times 1 minus x, and then we would FOIL that out. So that actually ended up being x squared minus 2x plus 1, which is what I wrote in my final answer. You had to go back and say when it was undefined. So we look at our original factored denominator, and you just set it equal to 0. So that's 1 minus x squared equals 0. Just take the square root of each side. That's 1 minus x equals 0, because the square root of 0 is just 0. Add x to each side to make it positive, so it's 1 equals x, which would make it undefined. That was a harder one. Let's take a look at B. So at first, I made a mistake. I forgot to put my parentheses, so I wonder if you guys did that as well. It's supposed to be 1 minus x, and I replaced the x with x squared minus 1. So I have to subtract this whole x squared minus 1. So the 1's actually do not cancel, because I'd have to distribute that negative to both of these terms, leaving me with 1 minus x squared plus 1. So really, in the denominator, we have 2 minus x squared. And hopefully you notice that x squared minus 1 was a difference of 2 squares. We had a lot of factoring mistakes with this one in the past. So x squared minus 1 becomes x plus 1, x minus 1. Nothing canceled out. This didn't factor at all. So this is my final answer. But I did have to say where it was undefined. So I set 2 minus x squared equals 0. I took the square root of each side. And technically, whenever you take the square root, you need to put a plus or minus. So it cannot equal plus or minus the square root of 2. The only reason why I didn't put plus or minus over here is because plus or minus 0 is just 0. If you wanted to, you could have technically done that, but it's not going to change your answer over here. It was just 1.